there. Quadratic equation. Yeah. We're not solving for the actual solution. We're just describing what it would look like. How many answers are there? What type are they? Okay. That's using a value that is called the discriminant, giving the number and type of solutions in a quadratic equation using what's called the discriminant. Discriminant, D-I-S-C-R-I-N-A-N-T, discriminant is a value given as b squared minus 4ac. Where does that come from in the quadratic formula? B squared minus 4ac is where in the quadratic formula? It's under the square root. I'm only looking at the part of the quadratic formula that's under the radical. Knowing what we know about square roots, I can describe the type of solution, how many they are. What if the square root is negative? Is that going to be a real solution or an imaginary solution? Imaginary. If you're discriminant, if b squared minus 4ac, if the number you're taking the square root of is less than 0, wouldn't that give imaginary answers to the quadratic equation? Makes sense. In a quadratic equation, if b squared minus 4ac is less than 0, when you set up the quadratic formula, you're going to end up taking the square root of a negative number, and therefore having two imaginary solutions. Back here on the wall, when you took the square root of negative 36, didn't you get two imaginary solutions? Yeah. Okay. If the discriminant is 0, what's the square root of 0 that you just answered a minute ago? If b squared minus 4ac is 0, what's the square root of 0? 0. So there's just one answer. If the discriminant value is 0, that quadratic equation will only have one real solution. And then lastly, what if the discriminant was positive? If b squared minus 4ac is positive, greater than 0, what's the square root of a negative number? How many answers would there be if I take the square root of a negative number? There would be two of them because I have to have plus and minus. And they'd both be real because square roots of positives are real and not imaginary. Now I can keep going a little bit further and describe these solutions as both rational or irrational. What makes the square root of 81 greater than the square root of 50? So I think the square root of 81, it has a rational solution. 9 is a rational number. A rational number I can write as a fraction, 9 over 1, for example. Square root of 50, 50 is not a perfect square because its answer only simplifies down to 5 root 2. This is an irrational number. It's not a nice whole value like 9 would be. This would be some weird looking decimal, not a rational number. So if you have a positive discriminant, you're going to have two real solutions that are sometimes rational if the discriminant is a perfect square, or irrational if it's not a perfect square. Using those notes and what we think about square roots, we can describe the number and types of solutions by seeing if the discriminant b squared minus 4ac is less than 0, greater than 0, or equal to 0. Let's also look at the graph of these equations. Up on the television screen, I've got Desmos pulled up. And I've got the general form, ax squared plus bx plus c with lots of different sliders that I can change the A, B, and C values of. I've also got b squared minus 4ac. This is called what? Starts with a D. Discriminant. Desmos is calculating the discriminant for me based off the A, B, and C values I'm giving it. Right now it's 1, 1, and 1. 1 squared minus 4 times 1 times 1 is negative 3. Is negative 3 more than, less than, or equal to 0? Less than. So I have a negative discriminant. Therefore, I'm supposed to have two imaginary solutions. How many answers, how many x-intercepts, how many places does this graph cross through 0? Does this ever touch the x-axis? Is there any x value that makes this equation equal to 0, in other words? Does it ever cross the x-axis? This is the y-axis. Does it ever cross the x-axis, left and right? No. So it has imaginary solutions, or no real solutions, because there's no x value that makes this equal to 0. Because your discriminant is negative. Now let me change this a little bit. I'm going to move c down to negative 1. What did that change to the discriminant? Look at b squared minus 4ac down below. What is the discriminant now? 5. The discriminant is positive. So how many solutions are going to show up on the graph? How many places does this cross through the x-axis at? 2. There's 2 numbers that make this equation equal to 0 because it has 2 roots, or 2 x-intercepts. I've got different A, B, and C values. A is 1, B is 2, C is 1. What's the discriminant that Desmos is calculating for us now? It's what? 0. So how many solutions are there when the discriminant is 0? How many x-intercepts are up on the screen? How many roots are there? 1. It has 1 solution. There's only 1 number that makes this equation equal to 0 as a root. That's negative 1. Because when your discriminant is 0, what we know about taking the square root of 0 is that there's only 1 answer. Square root of 0 is just 0. Okay, so let's try this on our own for a couple of different ones. I've got 3 different quadratic equations on the board. I want to find the discriminant and use it to give the number and types of solutions for each equation. We're not solving, we're just describing what the solutions would look like if we were to actually do all the work. Discriminant is b squared minus 4ac. It's just a part of the quadratic formula that's under the radical. So what's the a, b, and c for this equation? What's a? I need a of 1. There's a 1x squared. Pulling out the coefficients. What's b and c?
4 and 7.
Negative 4 and 7. The sign comes with it. Okay, well, just plug those numbers in to the discriminant expression, b squared minus 4ac. We have a b value of negative 4, so negative 4 squared minus 4 times 1 for a and 7 for c. Essentially, we're just finding out what number I would have to take the square root of if I did the whole quadratic formula setup. Can everyone type that into your calculator? Exactly as I have it written in red. Negative 4 squared minus 4 times 1 times 7. Use parentheses there, Isabella. Just like I have it written up on the board. What number are we getting? Negative 12?
Yeah.
Oh, that's right, yeah, negative 12. I had it around my head. Negative 4 squared is 16. 4 times 1 is 4. 4 times 7 is 28. So 16 minus 28, or negative 12. There's the discriminant. Over here to our notes. Where does negative 12 fall in this chart? Is it less than 0, equal to 0, or greater than 0? Yeah, John. It's less. So here's how you describe the solutions. There are 2 of them. They're both imaginary. I have no idea what they are. I just know that they're going to be both imaginary solutions. Since I have Desmos pulled up, let's just graph what this would look like. A is 1, negative 4 and 7 for B and C. How many roots are there for this graph? How many x-intercepts or solutions are shown on the screen? Does it ever cross through the x-axis?
No.
0. There's 0 solutions because both of the solutions we would find would be imaginary. I can't graph imaginary. At least not up there. Let's try another one. Same question, different numbers. A, B, and C are what, and what?
2 to the negative 3.
All right. So let's plug those into the discriminant. 2, negative 5, negative 3. I want to know if I did the whole quadratic formula, what number am I taking the square root of? And how can I use that concept to figure out how many solutions there's going to be? So b squared, right, negative 5 squared, minus 4 times 2 for A, negative 3 for C. Same question. Plug it in your calculator. What value does it spit out?
49.
I hear some 49. Anybody get anything different? Negative 5 squared should be 25. 4 times 2 is 8, times 3 is 24. That's the double negative here. We're going to add 24. Yeah, I agree. 49 looks right. If we're taking the square root of 49, that's the square root of a positive number. Would that be real or imaginary? Real. How many answers are there? There are 2 of them. Now, whenever the discriminant is positive, we can actually classify these solutions more as either rational or irrational. Is the discriminant of 49 a perfect square, or is it not a perfect square? So we have rational solutions. We did an example of that back here. 81 is a perfect square, so you just got out 9. 9 is a nice rational whole number. 50 is not a perfect square, so this would be an irrational number. It's not going to be quite as nice a solution. So two real solutions, both rational. Negative 3, 2. Okay, I've got that graph for 2x squared minus 5x minus 3 up on the screen. How many x-intercepts? How many roots do you see on the graph? 2, rather than the previous example when there were actually no x-intercepts, right? Well, I can actually click on these and find the real answers. They are negative 0.5, negative 1/2, and 3. Both nice, rational answers. Negative 1/2 and 3. Try the last one. I'll let you try this last one on your own. 4x squared minus 12x plus 9 is 0. 4 for A, negative 12 for B, and 9 for C. And plug those three values into the discriminant, b squared minus 4ac. Use that number to describe the number and types of solutions for the equation in general.
You can even do it. Mine's smarter than yours.
I would first find the discriminant, and then look on the board to see what that means for the solution to your equation. How many answers would there be? What type would those solutions be? Let's see. 4. 12. That's supposed to say in 0 for the discriminant. Is that what we got?
Yeah.
Let's see here. Negative 12 squared minus 4 times 4 and 9.
Up there.
That's 144 minus 16 times 9. That's 90. Yeah, that's 144. 0. Where does 0 fall in this chart of notes? One solution. How many x-intercepts are on the screen behind me? How many traces does that have a root of? Just one. There's only one answer. The vertex is on the x-axis, so the only solution is x equals negative 1.5. That's one real solution. Okay, why don't you grab your packet out? Let's take the last half of class here, and I'll give you guys some time to work on getting some practice on quadratic formula and quadratic discriminants.